On Christmas Eve in 2021, NASA's InSight lander received a gift of sorts, a new discovery. InSight recorded a significant Mars quake. That's what we call quakes on Mars. But scientists learned only later the cause of that shaking, because the Mars Reconnaissance Orbiter, also known as MRO, was able to see from space what the lander detected. I'm Raquel Villanueva, and I'm your host today here at NASA's Jet Propulsion Laboratory in Southern California. Today's science team members from the InSight lander and MRO mission will explain how data and images from their spacecraft contributed to the discovery. Joining us virtually are Bruce Banerdt, InSight Principal Investigator at NASA's Jet Propulsion Laboratory; Liliya Posiolova, Orbital Science and Operations Lead at Malin Space Science Systems; Ingrid Daubar, InSight Impact Science Lead at Brown University; and Lori Glaze, Director of NASA's Planetary Science Division from NASA headquarters. We'll be taking questions after hearing from our speakers, so if you're a member of the media on the phone lines, press *1 to be put in the queue. And if you're on social media, use the hashtag AskNASA. I'll now hand it over to Bruce.
Hi, everyone. I'm Bruce Banerdt. I'm the Principal Investigator of the InSight mission. I'm speaking to you here today from Lockheed Martin Space, where the Spacecraft Operations Center is located. InSight has been on the surface of Mars since November of 2018, listening with its seismometer and various other instruments, weather instruments and so forth, to what the goings-on Mars. And we're here today to talk about a new discovery that we're really excited about in terms of the first time that impact's actually been observed as it happened by a seismometer, and then observed also from space by the orbital cameras. Before we get into that, though, I'd like to tell you a little bit about the spacecraft status on Mars. Can we have the first image, please? As you probably know, as InSight's been sitting on the surface of Mars for the last 4 years, it's been collecting a lot of dust on its solar panels. This is a picture of the solar panels a couple of months ago, and you can see that it's really, really dusty, and that's cut down our solar power. And we've been sort of cutting back on the operations of the spacecraft as that's happened in order to squeeze out as much science data as we can. About a month ago, we got an additional challenge to the spacecraft. If I could have the next image. This is a global mosaic of Mars. It was taken over the course of a day, and it shows a large dust storm in the southern hemisphere that started kicking up about a month ago. If you go to the next image, you can see the dust storm shown in the orange, so you can see where it is. Fortunately, that dust storm did not move over InSight itself. InSight is over on the right side of this image, one of those spots on the right side of the image. And so that was really fortunate, because if it had passed over the spacecraft, it would have darkened the solar panels, and we probably would have lost the spacecraft. But unfortunately, since this is such a large dust storm, it's actually put a lot of dust up into the atmosphere, and it has cut down the amount of sunlight reaching the solar panels by quite a bit. We went from about 400 watt hours per sol, which is the units that we measure the spacecraft power in, down to less than 300. We had to shut off the seismometer for a few weeks. We are now operating the seismometer again, only 1 day out of 4 at this point, to conserve our power. But even at that relatively small amount of use, the batteries are still slowly being depleted. And so what we believe is, in the next short amount of time, perhaps somewhere between 4 and 8 weeks, as best we can predict, we expect the lander to not have enough power to operate any longer, and will lose contact with the spacecraft. So that's a sad thing to contemplate, but InSight has been working marvelously for the last 4 years. We've gone well beyond the intended lifetime of the mission, which was 2 years. We've been collecting data. And even now, as we're winding down, we're still getting these amazing new results. If I can have the next animation, this is an image showing that the relative locations of the InSight lander over on the left-hand side of the image, and this impact that caused a crater that we were able to pick up with our seismometer and that was later imaged with the Mars Reconnaissance Orbiter. I can show you the seismic data, and actually you can hear the seismic data. What we've done here is we've speeded up the vibrations that we measured with the seismometer up into the range that we can actually hear with the human ear. So we've sped it up about 100 times. If you were actually on Mars, you would feel the shaking, but you wouldn't be able to hear it. But this way, we can actually, transmit it over the internet, and you can experience it. This is about 45 minutes of seismic data, and you'll be able to hear it in a little less than half a minute. So if we can go ahead and roll that animation now, you can listen closely to the sounds of Mars. And what you've experienced there is the first bulge, and you can see in the image was the P wave coming in, the first wave that comes from any seismic event, and then the big bulge there is the S wave, and then buried in that is actually the surface wave, which is one of the real interesting findings from this new event, and we'll be talking about that a little bit more later. So with that, I'd like to hand it over to Liliya Posiolova to talk about how this really interesting discovery was made.
Hello, everybody. My name is Liliya Posiolova, and I work at Malin Space Science Systems. We design, build, and operate cameras on spacecraft. May I have my first image, please? I oversee operations of CTX, Context, and MARS-C, Mars Color Imager, on board of MRO, Mars Reconnaissance Orbiter spacecraft. In December of last year, a meteoroid struck Mars and created the largest fresh impact crater we have observed in 16 years of MRO mission. May I have my next image, please? When we first saw this image, we were extremely excited. This was nothing like we've seen before. It took entire view of the CTX image. It's a 30 kilometers width, and even we needed to take 2 more images on the sides to capture the entire protuberance area. We do see regularly small craters with in our CTX field of view. And how do we do it? We acquire CTX images based on our various scientific objectives, and we inspect them for any changes. And typically what we see, it will be like a little smudge, and then we compare to all the available previously data sets to confirm that it is fresh or not fresh crater. And typically they are on the size of up to 20 feet, small craters, and time constraint we can do few years, maybe occasionally down to 1 year. The protuberance that this impactor created was so large, then we thought maybe we could see it in our other camera view. It's our, may I have my next image, please? It's our low resolution weather camera, but it takes daily global images of Mars. On the right, you see a feature that created by this impactor. And to see that strong of a signal in that camera view, it's huge, very rare. We were able to time constrain this impact down to about a day, slightly over 24 hours. And then I recall that InSight reported back in December that they recorded this large seismic event on Christmas Eve. When we compare seismic epicenter with location that we pinpointed from the orbit and the time, we were able to match this large seismic event to our large impact crater. This is by far the largest jointly observed crater recorded seismically and observed from the image, from the orbit. May I have my next slide, please? As bolide travel through the Mars atmosphere, it creates a muck cone. And as a result of it, you see dust perturb on the left of the crater. A lot happens as the meteoroid strikes Mars. Rock gets fractured. There is atmospheric blast. Ejecta gets thrown out. Crater gets excavated. And effect of that dynamic all got preserved in the Martian surface, and we captured it in our CTX image. We see the crater itself at about 150 meters in diameter. We see bright patches of ice. This is most equatorward ice we've seen on Mars. The ability to tell what happened when and what activity occurred, along with the largest impact crater, are two huge discoveries and demonstrates the value, increased value that joint work of two missions brings. And I will turn to Ingrid to look at more details of the impact itself.
Thanks, Liliya. My name is Ingrid Daubar. I'm on the team for the HiRISE camera, which is another camera orbiting Mars on MRO. If I can have the first visual, please. HiRISE is a high-resolution color stereo camera that lets us see things as small as a desk on Mars. I also help lead the Impacts Working Group on the InSight mission. HiRISE and CTX have been showing us new craters, as Liliya said, forming on Mars for a while now. So we were hopeful we could detect some of these with the InSight mission. We want to study impacts with InSight because they can tell us not just about the craters themselves and the cratering process, but also about the interior and the atmosphere of Mars. Sources with a known location and size can help calibrate all of the other data we've gotten from InSight, all those quakes where we don't know the exact epicenter. After 3 years of listening, we thought impacts probably have to be either very close to the lander or very large to be detected seismically. We recently found 4 small impacts close to InSight, but we never thought we'd see anything this big. So we were super excited to hear about this discovery by Liliya and her team and have the chance to study it in more detail with HiRISE. Could I have the next image, please? From this HiRISE image, it was immediately clear that this is the biggest new crater we'd ever seen. It's about 500 feet wide, about 2 city blocks across. And even though meteoroids are hitting the planet all the time, this crater is more than 10 times larger than the typical new craters we see forming on Mars. We thought a crater this size might form somewhere on the planet once every few decades, maybe once a generation. So it was very exciting to be able to witness this event. And to be lucky enough to it happened while InSight was recording seismic data, that was a real scientific gift. For comparison, the Mars quake this crater caused was a magnitude 4 quake, which on Earth is big enough to be felt, but not big enough to cause a ton of damage. About 1,000 or so quakes of this size happen on the Earth every year, but Mars is less tectonically active than the Earth. So for Mars, this was a pretty big one. Can I have the video, please? Most exciting of all, we saw clearly in the high-resolution images that a whole lot of water ice had been exposed by this impact. You can see in this flyover video of the 3D data, boulder-sized chunks of ice in the crater's ejecta, as well as splotches of ice thrown across the landscape outside the crater. This was surprising because this is the warmest spot on Mars, the closest to the equator we've ever seen water ice. So scientists are going to be able to use this to constrain the past climate conditions on Mars, when and how this ice was deposited, buried, and preserved up until now. This is a huge opportunity to study a really large impact event from both the orbit and the ground, a reminder of how privileged we are to have multiple missions studying Mars at the same time. It's been really exciting and fruitful to be part of these 2 projects working together. And now I'll hand it over to Lori Glaze.
Thank you so much, Ingrid. So InSight, what an amazingly successful mission where we've learned so much about Mars's crust, the interior, and more. As you heard from Bruce, sadly, we're likely nearing the end of the InSight mission, but what an awesome capstone science result to end on. I mean, literally going out with a bang. The observation of the December 24 impact by the InSight seismometer, as well as the orbital imaging, is really exciting, not just for gathering important new information that will refine our understanding of the crustal structure, but for other really important science as well. As you heard, it's the largest impact crater seen on Mars since we've been observing and watching. Asteroids are found throughout the solar system, and they play a really important role in planetary surface processes. So these observations are going to help contribute to that knowledge. To give a little context on this particular asteroid, the expected size range of the object that created the crater was likely between about 5 and 12 meters across. And, you know, asteroids of that size actually enter Earth's atmosphere on the order of about once a year. We see those pretty regularly. But because Earth has a thicker atmosphere, asteroids of this size burn up and are generally pretty harmless. If I could have the first graphic, please. I just want to speak for a moment about the importance of the discovery of ice, you know, just below the surface. This is really an exciting result. We know, of course, that there's water ice near the poles on Mars, but in planning for future human exploration of Mars, we'd want to land the astronauts as near to the equator as possible, and having access to ice at these lower latitudes, that ice could be converted into water, oxygen, or hydrogen. That could be really useful. If I could have the second graphic, please. So let's just go back to where Bruce started. You've heard that the power production on InSight has been dropping, that the mission will likely end sometime in the coming 4 to 8 weeks, in the next couple of months. This mission has been a really big success in the 4 years it's been operating. I want to take a moment to acknowledge this incredible team that has met many challenges along the way. They've met the challenges of the soil of Mars not cooperating and the challenges of trying to deploy the mole with the heat probe, challenges of waiting for those quakes, those first quakes, and waiting for the data to really start delivering what we were looking for. And of course, the dust accumulation and the valiant attempts by the team to extend the lifetime of the mission by cleaning some of that dust off the solar arrays. I've known Bruce and several of the science team members for many, many years, and I know how much emotional energy goes into those years of planning and execution of a mission like InSight. And I know it's going to be hard for the team and for all of us to say goodbye, but I just want to say I couldn't be prouder of all this team has accomplished. I want to close by saying thank you to Bruce and the entire team for all they've done to advance our understanding of Mars. And with that, we'll go back to Raquel.
Great. Thank you so much, Lori. Now we'll move it on to Q&A. So if you're a member of the media on the phone lines, you can press *1 to get put in the queue. And for social media, you can use the hashtag #AskNASA. And we do have some social media questions coming in. First off, Mrs. Whiskers1 on Twitter asks, has there been anything that surprised you? And Bruce, I think she is talking about InSight in general.
Well, there's been a lot of things that surprised us, actually. It would have been a pretty boring mission if we didn't get surprised. We were surprised at first by how quiet Mars seemed to be in terms of seismic activity. It was 3 months before we actually even saw an earthquake, and that was... My fingernails were getting pretty short by the end of those 3 months because we were really depending on getting Mars quakes. Once we started getting Mars quakes, we realized that what we'd done is we'd landed in the windy part of the year, and so all the Mars quakes were getting covered up by the wind, and so that was a big relief. The next big surprise was the issues with the mole. We were surprised by the properties of the Martian soil. It was unlike the properties of the soil that we had seen previously at the Viking landing sites, at Spirit and Opportunity and Curiosity. InSight landed in a spot where the soil was a little bit different than what we expected, and that made it impossible for our mole to penetrate. So that was an unpleasant surprise, but scientifically it was actually very interesting because that showed that Mars was a lot more varied than we had thought before. Finally, some of the results from our seismic experiment, the results of the deep interior, surprised us. The core appears to be quite a bit larger than we had imagined. We thought it was going to be about 1,700 kilometers or so, and it was actually over 1,800 kilometers in radius. And that has some really important implications for the evolution of the planet Mars itself. And so that's a big surprise, one that we haven't actually been able to incorporate into our theories yet. And so this impact was sort of the latest in a long series of surprises that we've had over the mission.
Thanks. You summed it up well. Mars is full of surprises. Thank you, Bruce. Now, we do have a caller on the line, and if you could please direct your question to one of the speakers. We have Megan Bartels from space.com.
Hi there. Can you hear me okay?
Yes, we can.
Perfect. Thanks for taking my question. I was hoping, Bruce, if you could go into a little more detail about the significance of detecting surface waves for the first time, and then sort of how to use that information to better understand the crust.
Yeah, I would love to do that. I mean, this is the surface waves were something that we had anticipated using in our data analysis from the very beginning of our planning. We thought we were going to use surface waves to locate quakes, use the surface waves to probe the structure of the crust, the upper few tens of kilometers of the planet. But for the first 3 years of the mission, we saw no surface waves. And we believe that that's because the Mars quakes are a little bit deeper than we anticipated. And so the surface waves aren't really developed large enough to be able to detect with our seismometer. So now that we do have surface waves, it's already telling us a lot of really interesting stuff about Mars. The nice thing about surface waves is they tell you about the crust, not just where the lander is sitting, but they look at the crust as they're moving across the planet. So the whole path between the event, in this case, the impact, and InSight is sampled by these surface waves as they move across the planet. And so we have an idea of what the crust is over this fairly long path. It's about 3,500 kilometers for one of these events, and almost 7,500 kilometers for the other one. And we find that the crust is different. Again, the InSight landing site is a little bit unusual, or at least different than the pathway that these surface waves took. And so we found that the crust under InSight has a layer about 10 kilometers deep that is a little bit lower velocity, lower density than what's indicated by the surface waves. So surface waves are telling us about the crust, not just at our one point, but over a wide area on Mars. The other thing that is great about the surface waves is that they help us to refine our location, refine our seismically determined location. And we find that by incorporating that with the body waves, the P and the S waves, that helps us again to zero in on the location in which the impact is found.
Thank you for your answer, Bruce. Now, remember, if you're a member of the media on the phone lines, you can press *1 to get put in the queue. And social media, use the hashtag AskNASA. And we do have some more social media questions coming in. We have Andrew on Facebook who asks, how often do you discover a new impact crater? Liliya, Ingrid, would you like to both take that?
Sure, I can take that. So CTX has been looking for these ever since MRO went into orbit about 16 years ago. And Lily can tell you more about the CTX process to find them. But since then, we found about 1,200 new impacts. Sometimes there's a couple craters there, sometimes there's just one. But again, they're much, much smaller than this one.
Yeah, thank you for the question. So, yeah, indeed, we relatively regularly do find them, but again, they are much, much smaller, and they, on our CTX field of view, they look like a little smudges. So when we compare to all the previous data sets, we're looking for that change. And sometimes we see what maybe looks like a fresh crater, but then if we look at all the previous data sets and we find that, say, previous image was taken 3 years ago, oh, it's still there, and then 5 years ago. And if that's all the previous images we have, we can call them a fresh crater. But yeah, we find many fresh craters, and as Ingrid mentioned.
Great, thank you. And we have another caller on the line, Mark Carreau from Aviation Week and Space Technology.
Thank you, and I apologize if you already answered this, but what was the distance, or what is the distance between InSight and the impact crater?
That's about, thanks for your question. It's about 3,500 kilometers between the where InSight is located and the location of this crater.
Great. Thank you, Mark. And also on the line, we have Ken Kramer from Space Up Close.
Hi, thank you for doing this. Very exciting results, and thanks for taking my question. I want to ask you about the ice that you found. I'd like to know, how surprising was it to find ice at that particular location? How long did it remain on the surface? Because I know ice melts, evaporates pretty rapidly there. And I'm wondering, you have radar instruments there too. What did the radar instruments tell you about subsurface ice in that location? Thanks. Bye.
I can take that. This was a big surprise because this is the closest to the equator that we've seen ice exposed in an impact. However, there have been a number of all these other impacts that we found, much smaller and closer to the poles, that have also exposed water ice. Before this, I think the closest one was a few degrees north of this, so it wasn't totally out of range of what might be expected, but it was still very surprising. Of course, this crater is so much bigger than all the other ones we've seen, and it excavated so much deeper that we're getting down deeper in the shallow subsurface. And then your other question was about, how long the ice lasts. Yeah, so we do see evidence of sublimation of ice that's been exposed in this way when we use HiRISE to take images over and over again to monitor the sites. And we can actually see the ice disappearing in most cases. And it doesn't last long. It's not actually stable at the surface at these locations. This one, again, it's fairly new, but we have seen some evidence of that happening, but I don't think it's really been studied in detail yet.
Anything about the radar results from that area about ice?
Not to my knowledge.
Thank you.
Right. Thank you. And we also have another question coming in on social media that is related. Bart on Twitter asks, how would you know if the ice wasn't contained to the meteorite itself?
I can take that too. Yeah, that's a really good question. We thought about that. Like maybe this was a cometary impactor that was just made of ice, and what we're seeing on the surface is just splashed out from the impactor itself. But an impact of this size would actually destroy the meteoroid that came in to hit the surface. We wouldn't expect much, if any, of the original impactor to survive this high energetic. It's about it's a high energy explosion. So we can look at that, and we can also look at the locations where the ice is found, and that also shows us evidence that it's probably not from the impactor itself, but rather was excavated from below the surface.
Great, thanks, Ingrid. We have one more. Oh, okay. We actually are out of questions for today, so that is all the time we have today. Thank you, and I'd like to thank all the speakers for their time today. So to stay up to date with InSight, visit mars.nasa.gov/insight and follow @NASA InSight on Twitter and Facebook. And for more information on the Mars Reconnaissance Orbiter, visit mars.nasa.gov/MRO. I'd like to thank everyone for watching today.